Right, first, I apologize for the little clicking in the background. I'm making lunch, and that's my toaster oven. Okay, so this is the sixth FRQ from the 2018 AB exam, and it's the differential equations FRQ. So first they give us a slope field and they want us to sketch the solution curve through the points that they gave us, and they actually drew the points on there. So the solution curve through the point 0,2, here's the point 0,2 right there, and that's actually just a horizontal asymptote. So that one is pretty easy to trace. Make sure you have arrows on either end, so you're showing that it continues outside the bounds of the graph. And then the point 1, 0 is over here, so I'm going to kind of follow those, so it's going up like that. I'm not going to stop there. And you can see that there's some symmetry to this. I'm just going to try to get that same symmetry on the other side. All right, so there's my two solution curves. Part B says to let y equals f of x be the particular solution with the initial condition 1, 0. Write the equation of the tangent line. So, and then use that equation to approximate something else. So what I need to do first is take the derivative and evaluate it at that point 1, 0 to figure out what the slope at that derivative is, or the slope at that point, sorry, is. So I've got 1/3 times x times y minus 2 squared, so that's 1/3 times 4, so 4/3. So our tangent line is going to be y minus 0 equals 4/3 times x minus 1. And so f of 0.7 would mean I'm going to plug in 0.7. So that's 4/3. 0.7 is 7/10. So I'm going to go ahead and do 7/10 minus 1. 7/10 minus 10/10 is -3/10. And so when we plug in 0.7, we get -4/10, which is -2/5. You're welcome to do decimals if you prefer, or honestly probably leave the answer right here. I think that should be okay as well. All right, part C wants you to find the particular solution to the given differential equation with the initial condition 1, 0. So that means we're going to do the separable differential equations. We're going to have a plus C in the problem. We're going to solve for C, plug it back in, get the final answer. So I've got dy dx equals 1/3 x times y minus 2 squared. So I'm going to go ahead and divide the y over. And then I'm going to integrate each side. And on the left side, I do have a u substitution problem. You can get away without doing it, but I'm going to go ahead and do it anyway. And so I end up with 1 over u squared, which is u to the -2. And so if I add 1 to the exponent, I get -1, and then I'll divide by -1. So that gives me -1 over u, because that's -1u to the -1, equals, I have 1, add 1 to the exponent, that's 2, divide by 2, so I've got 1/6 x squared plus c. I'll go ahead and plug the y minus 2 back in. Now, you can solve for C at any point. This would be like the first place where I could plug in 1, 0. What I've found is sometimes I like to plug it in right away. Sometimes it seems like that's more complicated and I'll plug it in later. Ultimately, depending on when you plug it in, your C could be a little bit different, but your final answer is going to end up the same regardless, as long as you do your work correctly. So I'm going to go ahead and plug in 1, 0 already. So I'm going to say -1 over 0 minus 2 equals 1/6 times 0 squared plus C. So I've got positive 1/2 equals C. And now I'm going to go ahead and write what I've got. Okay. And then I'll go ahead and multiply the y minus 2 to the other side and then take this part and divide it back over. And then I'll go ahead and add the 2 over here. And it didn't want us to plug anything in, that's the final answer. Now, if you look at the answer key, that's not the answer key has. What they did is they got rid of the fractions in the denominator. And so if you want to do that, you would multiply by 6 on the top and 6 on the bottom. And then when you do that, the problem does work out the way it's supposed to. Dang it. I just realized I made a mistake right here. I was supposed to plug in 1, not 0. I should be re-recording this video, but I don't want to. Okay, sorry, I should have plugged 1 and not 0. It makes the answer different, but not too different. Okay, so we've got 1/2 equals 1/6 plus C. So to solve for C, I've got 1/2 minus 1/6. So 3/6 minus 1/6 equals C. So that's 2/6, which is 1/3. Okay, I'm going to go ahead and go to the back. Okay, so I have -1 over y minus 2 equals 1/6 x squared plus 1/3, not 1/2, slightly different. But we can do the same thing here. So we'll picture taking that y minus 2 and multiplying it over here. I'm going to hold it there, take this, divide it back over. And so I've got -1 over 1/6 x squared plus 1/3 equals y minus 2. And then I can add the 2 over. Sorry, guys. My bad. Very similar. So again, if you wanted to get rid of that, the fractions on the bottom, just multiply by 6 over 6.